A pleasant greetings to all. In this video, I am going to explain the problems in coupled circuit. Problem number 1. The equivalent inductance of the network is. Here we are having two windings, L1 and L2. The first winding, current is leaving the dot. Second winding, current is entering the dot. Both the direction of current is opposing with each other. The mutual inductance is negative. So what is answer? L1 plus L2 minus 2M is the correct answer. Option A is correct. Next problem number 2. The effective inductance of the circuit across the terminal A, B in the figure shown below. This is the first inductive coil, second inductive coil, third inductive coil. Have to put the current. The first one, current entering the dot. The second coil, current leaving the dot. The third coil, current leaving the dot. Between this, the mutual inductance is M12. M12 is negative or positive? Negative, because the first winding current entering the dot, second winding current leaving the dot, M12 is negative. Next, consider the winding 2 and 3. 2, the current leaving the dot, 3 also current leaving the dot, mutual inductance is positive, that is M23. And next consider the third winding and first winding. The third winding current leaving the dot and the first winding current entering the dot. So the mutual inductance is again negative. So M13. Now I am going to find out what is the net inductance. Net inductance is L1 plus L2 plus L3 minus 2 into M12 plus 2 into M23 minus 2 into M13. What is the value of L1? 4. L2 is 5. L3 is 6. 2M2 that is minus 2. 2M23 is 2. So 4. M31 or M13 is 3 minus 6. Minus 6 minus 2 minus 8. Minus 8 plus 4 that is minus 4. Minus 4 plus 4 cancel. The answer is 11 Henry. Option C is the correct answer. Problem number 3. Impedance is as shown in figure. This is first one. This is a second coil and this is a third coil. The next mark the current. The current I that is leaving the dot. And second, the current is entering the dot. The mutual inductance is not given. And for the second and third, current entering the dot. Plus M23. And third and the first. Third and the first mutual inductance is given. The third coil current entering the dot and the first coil current leaving the dot. So minus M31. Now I am going to write the effective inductance L effective, that is equal to L1 plus L2 plus L3 minus 2M23 plus minus 2M31. What is L1? J5. What is L2? J2. L3 is also J2 plus 2M23 that is 20. M23 is 10J, 20J minus M31 also 10, 20J. Both the 20J are get cancelled. What is the net inductance? 9. J9 is the correct answer. Option B is correct. Problem 4. The equivalent inductance measured between the terminal 1 and 2 for the circuit in figure. I have to mark the current direction here. The first coil current entering the dot and second coil current leaving the dot. What is the effective inductance? L effective is L1 plus L2 minus 2M. That is the correct answer. Option D is correct. Next problem 5. The resonant frequency of the given series is L1, L2 and farad C is given. First of all, I am going to write the equation for resonant frequency. What is the resonant frequency? F is equal to 1 divided by 2 pi root LC. Here there is no single L. Two inductance are there. So I am going to find out the effective inductance, L equivalent, and then put the value C. Then we get the frequency. What is L equivalent? The first coil current entering the dot and second coil current leaving the dot. L equivalent is 2 plus 2 minus 2. Minus 2 is minus 2M, 2 into 1. 2 get cancelled. The answer is 2. What about capacitance? That is, what is the resonant frequency? 1 divided by 2 pi. What is root L? That is 2 into 1. 1 by 2 pi root 2 is the correct answer. Next problem 6. Given two coupled inductor L1 and L2, their mutual inductance M satisfies M is equal to L1, L2. Problem 7. The voltmeter in the shown circuit is ideal. The transformer has identical windings with perfect coupling. The voltmeter reads here N1 and N2. Has identical winding. Identical winding means N1 is to N2 equal to 1 is to 1. N1 by N2 equal to V1 by V2. V2 equal to what? V2 equal to V1 into N2 by N1. What is N2 by N1? That is equal to 1. So that V1 equal to 220 volt. V2 also 220 volt. Option B is correct. Next problem A. A single phase transformer is connected as shown in figure. When a voltage of 100 volt was applied across AB, the voltmeter connected across AC measured 100 VRMS. RMS is the root mean square. The turns ratio N1 by N2. Here this voltmeter reads 100 voltage. And here also the voltage is 100. So what about this CD voltage? VCD equal to 100 plus 100. So the VCD equal to 200. This voltage is 200 volt. Here N1, N2. I am going to find out N2 by N1. N2 by N1 is V2 by V1. What is V2? V2 is 200. V1 is 100. Cancelling this, we'll get 2 by 1. N1 is to N2 equal to 1 is to 2. That is the correct answer. Option B is correct. Next problem 9. In the figure of the transformer is ideal with adjustable turns ratio N2 by N1. The turns ratio N2 by N1 for maximum power transfer to the load. Okay, N2 by N1, that is equal to V2 by V1. Ideal transformer. So ideal transformer, there is no losses. V2 equal to what? I into Z. V1 is also I into Z. I2 or I both are equal. Ideal transformer, there is no loss. V2 equal to 1 plus J1. What is V1? V1 is 100 plus J100. 1 plus J1 divided by 100 into 1 plus J1. Both 1 plus J1 get cancelled. 1 divided by 100. N2 by N1 is 1 is to 100. Option C is the correct answer. Next problem 10. The resonant frequency of the circuit is given. Here I am going to find out the resonant frequency. Resonant frequency F is equal to 1 by 2 pi root LC. There is no single L. Two L's are connected in series with the same connection. There is no opposition here. The first winding, the current leaving the dot, and second winding also current leaving the dot. What is the equivalent inductance? L1 plus L2 plus 2 into M. What is L1? 10 plus 5 plus 4. The value is 19 millihenry. And what is the capacitance? That is 0.01 microfarad. 0.01 is 0.01 10 power minus 6. I have to substitute the value here. 1 divided by 2 pi. What is L? 19 into 10 power minus 3 into 0.01 into 10 power minus 6. 1 by 2 pi square root of 0.19 into 10 power minus 9. Next, 2 pi in the square root of, multiply numerator and denominator by 10 power 10. So 10 power minus 9 into 10 divided by 10. Okay, the answer is 1 divided by 2 pi into 0.19 into 10 is 1.9 into 10 power minus 10. Answer is 10 power 5 divided by 2 pi into 1.9. Option A is the correct answer. Thank you. Have a nice day.